and welcome. So today we're going to be working with a circle, and we have one tangent and one secant line. Just as a brief definition thing, a tangent line is essentially a line that will intersect with a circle at one point. So this is an example of a tangent line. A secant line just means that it intersects the circle twice. So that would be a secant line. Alright? What we're going to be doing is we're going to be solving for x using the information and diagram below. So first thing, fill in the information. Alright, we're given a lot of information. Let's use it to kind of look at what we're doing with it. So first off, we're given the measurement of the arc from Z to D. That's going to be this portion right here, and we're told that is 2. Alright, then we're also told that we have the measurement of arc G to D, which is this major arc, the larger arc right there. And we're told that one is going to be 4x squared plus x. And then last, most certainly not least, then we're told that we have the angle of ZCD, so in other words, that angle right there, is 4x. Okay, and now we're solving for x. So that's alright, well, when we're looking at this thing, we got to know the relationship between secant, tangent lines, and circles. And that relationship is as follows. Essentially, the angle that we're looking at, which is our blue dot right there, equals 1/2 of our major arc, which is the pink arc, minus the minor arc, which is our yellow arc right there. It's 2. And that is our relationship. So then, from there, all we have to do, plug in what we know. We know our angle is 4x. 1/2 is just a constant. The major arc is 4x squared plus x minus, and our minor arc is 2. Now it's just a matter of simplifying. Alright, now first thing I would do is, I personally don't like working with this 1/2, especially where I know that 1/2 is not going to go in evenly to everything there. So I'm going to multiply both sides by 2. And what this is going to do is when you multiply both sides by 2, that 2 and the 1/2 are going to end up canceling with each other. So then we're left with 8x on the left side equals, and then 4x squared plus x minus 2 on the right side. Alright, and now this makes it a lot easier to deal with. There are no more fractions, and now you're good to solve. Now hopefully bells are ringing that whenever you see a square, you need to solve this by using one of your solving quadratics methods, whatever that may be. Alright, I personally like factoring, so we'll start there, and if we can't, we'll do a different method. So subtract 8x both sides, we get 0 equals 4x squared minus 7x minus 2. And then from there, factoring looks for a GCF first. We don't have one in this case. Alright, so then we say, alright, middle number is a negative 7. Alright, the first number is 4, last number negative 2. Multiply them together, you get negative 8. So are there any two numbers that will multiply to negative 8 yet add to a negative 7? Yeah, that's a negative 8 and a positive 1. Right there, negative 8 plus 1 is negative 7. Negative 8 times 1 is negative 8. So then from there, it is you add to the middle term because you split the middle term. So we get 0 equals 4x squared minus 8x plus 1x minus 2. Because if you combine these together, you end up back at negative 7x. And then from here, it's just factoring by grouping. So split down the middle and find what's in common between your first two and last two terms. So in your first two terms, there is a 4x in common, so we're going to factor that out. Take an x, and minus 2 will be left. In our second term, there was nothing in common, so just pull out a 1. And x minus 2 will be left when we do. Alright, from here you'll notice parentheses are the same, so x minus 2 comes down. 4x plus 1 remains, right? If you take it out of here, 4x is there. Take it out of there, plus 1 is there. So equals 0. And from here, you're practically done solving, right? Then it's just a matter of setting each parenthesis, each factor to 0, and solving for x. So here we add 2, and we get x equals 2. Here we subtract 1, both sides, so then we get 4x equals negative 1, divide by 4, and x is negative 1/4. Now are we done? No. While you have solved for x, we were originally looking at various measures of arcs. And this is a geometric diagram, meaning you can't be having negatives inside of your answer here, right? If the segment remains negative when you plug it in. Negatives on their own are just fine, but they have to remain negative after you finish, which, ironically here, our negative 1/4 is actually kicking the bucket. Because if we have x equals negative 1/4, right, and we plug it into every x we have, so we plug it into these x's, right, and we also need to plug it into this one. Now you'll notice this is going to be the fastest way to do it. If we do 4 times negative 1/4, that's a negative 1. Now question, does a negative make sense here in a geometric diagram? No. Right? On their own, are negative angles possible? Yes. But from what we're looking at here, no, it won't be. Which means that impossible things are not going to happen. You can't have negative 1/4 there, which means that now we check our 2, right? Check both solutions. So instead of negative 1/4, now we're using x equals 2. Well, a positive times a positive is a positive. A positive number squared times a positive plus a positive number is positive, right? You don't even have to know what it is. It's not asking us to find the measure of that arc. It just says, is it positive? Yes. Great. It's an answer, and you're done. Okay. If you do want to plug it in, just to be sure, you can. Okay, that'll be 2 squared, which is 4, times 4 is 16, plus 2 is 18. 18 is a positive number, and it's good to go. Okay, and there you have it. That would be your answer. Thanks for watching.